Now we will discuss the concept of heat and work. So a system can interact with its surrounding in two ways. First is heat transfer and the second is work transfer. A system can interact means it can transfer energy or exchange energy with the surrounding by way of heat transfer or work transfer. Okay. So what is heat? So heat can be defined in this way, that heat is the energy transferred between two objects or two systems or between a system and its surrounding by virtue of a temperature difference between them. So if there is a temperature difference between two objects or two systems or between a system and its surrounding, then there will be transfer of energy between them. Okay, and it is called heat. Okay, so if there is no temperature difference between the systems or the objects, then there will be no heat transfer. And the form of energy that is transferred between two objects or systems due to a temperature difference, it is basically the thermal energy. Okay, so what is the sign convention for heat transfer? So if heat is transferred to a system, then it is taken to be positive and we can write it as plus Q. So heat transferred to a system means the energy of the system increases and we write it as plus Q. And if heat is transferred from a system to its surrounding, that is its energy of the system decreases, then the heat transfer is taken to be negative and we can write it as minus Q. So similarly for work, so how work is defined? So in thermodynamics, so in mechanics we know we define work as the product of the force and the displacement. Okay, displacement in the direction of the force. But in thermodynamics, work performed by a system is defined as the quantity of energy transferred from the system to its surrounding or to another system. Okay, so in the, so in case of heat, heat was the transfer of thermal energy. Here work is the transfer of mechanical energy. So the system will do some mechanical work and it will transfer mechanical energy to surrounding, or this mechanical energy will be transferred from surrounding to the system. Okay, then we can say that some work is performed. Okay, so in mechanics we know the work done can be expressed in some this way, that is work done is integration F dot dr. F dot dr is the product of this force and the displacement. Right. So suppose in we have this thermodynamic system. Okay, suppose some gaseous system. Okay, and there is in some vessel and we have one piston attached to it, and the piston can move up and down. So the gas molecules are colliding with the wall of the piston and they are applying a pressure P on the piston. So that is to say they are applying a force on the wall of the piston. And suppose the area of the piston is A. So what will happen? Due to the upward force which is being applied on the wall of the piston, suppose the piston will move by a very small distance, say dr. Okay, so this is the new position of the piston. Then what will be the work done? So the mechanical work done, dW will be F into dr. So what is F? F is the force applied by the gas molecules on the wall of the piston. So in terms of the pressure of the gas molecules, F is, we know, the pressure into area on which the force is being applied. That is A, which is the area of the wall of the piston. Okay, the surface area of the piston. So now we can replace F by PA in this equation. So PA dr. So now what is A dr? So dr, you can say it is the displacement in length. So what is displaced length, you can say? So what is A dr? A dr is basically this much volume. So you can say A dr is the displaced volume. Okay, or in this case you can say change in volume. Okay, change in volume, and it is increase in volume in this case. Change in volume. So it will be P dV. Okay. So in this way, suppose initially the volume was V1. In this way, as the piston is moving upward, suppose finally it acquires this position where this volume, new volume of the gas will be suppose V2. Okay. So in this, to make the volume from V1 to V2, what is the work done by the gaseous system? It will be W equals to integration of dW, which is integration initial volume V1 to final volume V2 P dV. So that is the work done for a thermodynamic system, where P is the pressure of the system and dV is the suppose change in volume. Okay. Now what is sign convention for work? So if work is done by the system, then that is energy is transferred from the system. So in this case you see the work is done by the system, because the pressure is applied in this direction, upward direction. The displacement is also has also occurred in this direction only. That is, the natural tendency of the system is to move in this direction, or the expansion happens in this direction. So in this case, work is done by the system and the energy is transferred from the system to the surrounding. Okay. So if work is done by the system, then energy will be transferred from the system to the surrounding. Then work will be positive. Okay, we can use dW. So in case of if work is done by the system, then energy will be transferred from the system to the surrounding, and the energy of the system will actually decrease, but work done by the system will be positive. We'll take it to be positive. Okay, that is, we can write plus dW. But if work is done on the system, suppose by some external agent, that is, suppose in this case, generally the piston should move upwards, okay, because the gas is applying a force on upward direction. But if by some force, suppose you apply a downward force on the piston, then piston will move downwards, which is not natural tendency of the system. Okay, because you are applying a force outward. Okay, so there is some external agent. In that case, work will be done on the system, and doing so, energy will be transferred to the system from the surrounding. In that case, work will be negative. Okay, minus W. So in this case, when work is done on the system, then energy will be transferred to the system from the surrounding. Energy will increase, but work done will be negative. In this case, work done is by the system. Energy will decrease, but work done will be positive. But in this case, work done will be on the system. Energy will increase, but work done will be negative. Okay.